I'm so honored to be able to kick off our last day of this amazing conference with you all. For those of you I haven't had a chance to speak with yet, I'm Catherine Davis, and I'm head of product at Addigy. So with that, this session is just 25 minutes, which I learned after I picked my topic. So I'm going to be going through it rather quickly. If you want to see a longer version of this, my colleague Bryce Carlson did a very similar talk over an hour, and they went 20 minutes over. It's available on YouTube from the Penn State Mac sysadmin. So for today's session, I'm going to go through a very quick history of OS updates through the ages, because it's important to understand how and why we got to the craziness we're at today. I'm going to go through a little bit of how things are today in terms of admin and end user experience. I'm going to go through 3 examples of debugging. Again, real wicked quick. If you want more examples, watch the Penn State admin version. Then I'm going to give a little bit of advice on how to provide feedback for these processes to your MDM vendor and Apple. So with that, let's dive in. We're going to step way back in time, all the way to my family's first Mac running Cheetah, Mac OS 10.0. Now, I won't tell you how old I was when this came out, but I did not care about updates yet. Now I do, and it's important to know. There were a couple different ways that you could do the updates for these early versions. You could do system preferences, the software update command line, and a fun thing that lived on for a while called combo update packages. Raise of hands, who's used one of those before? Okay, a lot of them. So for those of you that don't know, that was a fun way of doing, say you wanted like 10.4.1 to 10.4.11 or whatever version you had on your disk, because we had disks back then, it would do all of that kind of over the top for you, so you didn't have to go version. Now we'll jump ahead to Snow Leopard, which was the last version that was shipped on a disk. Then we have Lion, and this was the version where I started as an admin. More importantly, though, it was the first one where you could only get it from the App Store with that full installer. Now, you could still use the system's update pane to update. There's still those combo updaters. There's still the software update binary, so still several methods. But it was really nice because you could go in and get all of the full installers with any of those major minor versions and use the OS install binary to run it that way. We'll jump forward again to 2015, El Capitan, and with it, we have our first MDM updates using the Schedule OS Update, Available OS Update, and the OS Update status commands. At this point, you could still use a system preference pane or the App Store or software update command line or combo packages. So basically, we just have more and more ways that we can do OS updates. Well, when we get to Catalina, that's finally the end of the road for those combo updates. There's a good reason for that, though, because with the release of 10.11, Big Sur, there were some changes to how it actually does those installs. It only does what's necessary to prevent excessive read-writes as those SSDs start going out onto the Macs. This also caused some confusion in the admin world because Big Sur was the first version that required that local authentication for updates or upgrades from the volume owner. It was also the first version where you could use that authenticated reboot using a bootstrap via your MDM. We'll keep going until that next big shift, which is at Sonoma. This is where we get our first enforcement-specific declaration. We start to see the shift. It's also when Apple added that 403 response within MDM and ADE enrollment so that you could have a device update before it actually is enrolled in the MDM. Then, macOS 15, we get Pro Plus Max trademark, which is like another iteration on top of that, giving you the enforcement version and more granular controls on your update cadence. Now, only 14 slides in, we are at the current era. And this year at WWDC 2025, in case you're watching the recording later, Apple states that software update management using mobile device management commands, restrictions, and the aforementioned profile payloads and its queries is deprecated. Apple will remove it next year. going forward, organizations can manage and enforce software updates using only declarative management. So, where are we today? Well, today we have 3 types of managed updates and upgrades. We have those MDM updates, we have enforcement-specific declarations, and the newest we have is software update settings, global settings, automatic actions, declarations. So with that, what do those look like in terms of your admin and your end user experience? I'll go quickly through the MDM updates because, as I mentioned, this is going to go away. We don't know which version specifically yet, but maybe 27, we'll see. With this, you're able to send out that default install later or install force restart, which is really good for if you're like on the phone with someone and need to do it immediately. Declarative does not have a great use for that workflow. So there's some feedback tickets into Apple about that, but y'all could add some more. Now, enforcement specific varies a little bit from vendor to vendor, but a lot of it's basically the same. I have a screenshot here of how we do it in Addigy because that's where I work. But for example, if you were doing it in Jamf, you would just go in and set a specific date and time for when it would go and do that update. Each vendor does it a little bit differently, but basically what you're doing is you're assigning the time, and it's going to go in the local time for that device to a specified build version that you want, and you're able to include a URL if you want to give a little context to the user. That URL shows up here. Any user that's curious enough to go in there is going to see that, as well as the enforcement time when it's going to run. Now in this case, we're actually past due, so we see when it's going to go, and it's going to go hard. Now, with the global settings, with automated actions, it's a little bit different. It doesn't give you a specific time. It just says, hey, we're going to update later. And once that update is downloaded and prepped, it uses on-device machine learning to figure out what makes the most sense for the users on that device. Now, it will always try to do it overnight, if possible, as long as the criteria for that update is met. I'll go into the criteria a little bit more in a minute because it can get confusing. The update will try to use the last saved state of the password or the passcode from the last unlock of the device. It'll prompt the user if that doesn't work for whatever reason. There is also the option to try and use the bootstrap token via the MDM vendor. However, what we've seen so far in production, that's still a bit hit or miss. We filed a bunch of feedback tickets, but just, proceed with caution. So what does it actually look like when it happens automatically? These are some screenshots from a VM that I left running overnight. We can go into the install history in the system report and see that the update went through successfully at 1:19 a.m. Information from this gets sent up to your MDM vendor in order to provide that status in your management pane. Now with MDM updates, for timeline, you're sending that command, the command is acknowledged by the device, and that update's going to run with whatever setting, default, install later, force install that you've set. For the enforcement-specific declaration, you'll again be doing that target local date time, build version, OS version, and the optional URL. I'll go into a little bit of a breakdown of that by timeline. We've seen some this week, but I'll do it quickly. And then with settings declaration, with those automatic actions, we can choose a couple different things. So like, can standard users do the updates themselves if they get the prompt? You can control the number of notifications that they get. You can do the recommended release cadence for iOS. It's a little bit different than macOS with this method. And you can control whether the user is able to do the rapid security response updates themselves. Then, the important part related to the install, again, you're going through your enabling automatic actions, setting what version you're going to want it to do, and you're going to set a deferral window between 1 and 90 days. So say you choose 7 days, user's not going to see the ability to upgrade until 7 days. It'll download and prep then, use that on machine learning, give some more user-friendly prompts, and do the install. So I mentioned criteria a little bit, and unfortunately some of the documentation around this is lacking. But as a general rule, the main ones are it has to have a network connection so it can download the update. It has to have enough room on the disk so that it can download. It has to have the device either plugged in or a sufficient state of charge, which is more difficult than you'd imagine because every device version and devices have different requirements, and the knowledge base article that lists it out is buried in the beta documentation. You're pretty much safe if you have 50% or more on any device. You also need to not have any processes that are running that don't have a saved state, because those will interrupt the update. Now, I mentioned we're going to go a little bit more into the enforcement-specific declaration. So for this one, we have it set for 30 days from now. At that 30-day point, it's going to go ahead and notify the user. The user can go ahead and kick it off if they want to. At this point, it hasn't pre-downloaded yet, so they would go through essentially a manual update. Most users aren't going to do that, so we go to 14 days, about half that time. At this point, it's been downloaded, prepped, it's ready to go. If the user goes ahead and launches it, it just runs. They aren't going to do that, so we go forward to when there is just 24 hours left. At this point, those notifications will bypass Do Not Disturb, and they'll get a notification hourly until that final hour, where they will get it at 60, 30, 10 minutes, and finally 60 seconds, which is when they will see it for the first time. And if they're in a Zoom call or have something unsaved, sorry, it's going to reboot and go anyway. So hopefully they've seen it before then. But what happens if, say, it's closed, off network, all these things where it can miss that specific enforcement deadline? Well, it'll go through this again and again and again and again and completely fill up your log files because it truly just keeps going. Automated actions, on the other hand, are a little less aggressive. With that on-machine AI and some more user-friendly notifications, it's a significantly better overall end-user experience. However, we are giving up a lot of that more granular administrator control, and you kind of have to just trust that it's going to run in a day or two, maybe 3. Now, I've gone through a lot. I'm going to jump into 3 quick examples of debugging for some of these scenarios. Everybody's favorite part, right? I'll take a look at these. I am going to just do declarative. Again, check out that YouTube of the Penn State Mac sysadmin one if you want to see an MDM one. Now, I'm first going to take a look at an enforcement-specific update that's stuck in pending. In my MDM vendor's UI, I see that it's stuck in pending, but I don't have any additional information, which is pretty common to just have the status or some little pieces of information. So we go into it, I say, cool, but why? Well, that means it's time to hop into system logs, everybody's favorite thing. So with this, we're going to filter those by softwareupdate.install. Now, you could go more granular than this. This is my personal favorite place to start because it makes a nice timeline of events. You can find where things went off the rail, grab that timestamp, rip the filter off, deep dive into it. Now, for this specific example, we'll see the software update, and it has a failure reason. Now, this is one of the components in the status channel report. There's a whole bunch of stuff here. But specifically for the failure reason, we're seeing that the reason was the process was denied by another process. Please try again. Fun thing right now about where we are with Apple, you can't easily find what process blocked it, but you know a process blocked it. We can also see that the install state is prepared, and the OS version listed is 15.5, which is what we want. So we can deduce that it downloaded and tried to unpack it, but it's stuck there. So why is it showing blank in the MDM UI? Well, oftentimes, they're much more simplified. They don't have all of the criteria in the system logs. In the case of Addigy, we chose to make it more verbose after we realized some of these things. But in the case of new objects or things that Apple has released, oftentimes it's just the status that gets put in. So you're not getting the full picture like you would if you went into the logs. We also, in that example, had a blank install reason. However, here's a list of some install reasons that you might see. Most of them are pretty self-explanatory. if you went and triggered it through Setup Assistant, the code is Setup Assistant. So pretty straightforward. You're going to see declarative most frequently if you're using declarative management. Now, my next example, I will admit I shamelessly stole these screenshots from Bryce, but this example is going from macOS 15.4 to 15.4.1, and we're past our set enforcement time. The device is currently impending. So we're just going to look at how that progresses through those logs. If we hop into the console and look at the install reason, we can see that initially, before the device actually got that declaration of past due, it's kind of boring because it doesn't have anything it thinks it needs to do, and that's good. Until we wind up going over to the update subscriber DDM controller, and we see that come down with a scheduled declaration. If we look specifically at the bottom 3 lines here, we can see that declaration information with the enforced install date, which in this case, past due, includes the version number, and in this case, we've got notifications enabled for the declaration. So if we hop back into that update status, we'll see that the failure reason is blank. It hasn't failed yet, so that makes sense. The initial install reason is marked as declaration, and the install state is none because it hasn't actually started that install yet. The pending version is what we want it to be, 15.4.1. So after it starts downloading, the next step, if a user were to go into system settings at this point, they would see that the update's downloading and that it's about to happen. Now, after a little bit of time and that download completes, the install state will shift to prepared. Then the install state will shift from prepared to installing if it meets all the criteria and everything's good on that device. It then goes through that upgrade and does its thing. Then, if we go back, everything, kind of gets cleared out. It no longer has an install reason or state because it did the thing. So logs are boring. That's good. So my last example is on iOS, and we're going to go ahead and do that automatic actions, which is a little bit different. I was able to choose iOS for this one because with the way automatic actions is architected by Apple, the status channel and the update status is very uniform across all the platforms, so it's a very similar experience, which is awesome. For this particular example, we're going to go to iOS 18.6 Beta 3, since it's part of the Apple Seed IT for Beta. There's a 1-day deferral that's been set, and automatic actions have been enabled since we need that. First thing we're going to see if we hop into those is that the device gets the declaration. It sees that it wants to be in that Apple Seed Beta. It doesn't have an install state yet because there's no version yet. It will do a query and see what versions are available and see what it should do. Once it does that query, it says, hey, there's a version for you. It goes out and automatically downloads it. So now we see an OS version of 18.6 with a build version ending in 73B. It's in the prepared install state. Now I'm going to let this example device sit on my nightstand plugged in overnight. And it's not going to update. Okay, weird. Well, what wound up happening in this case is that we get a failure reason in there that says code 20, installation key bag required, passcode locked message in there. So what happened? Well, after the device was last rebooted, it hadn't been unlocked with that PIN code. So even though it was plugged in, had network connection, all that fun stuff, it failed. However, it'll continue trying until it's not in that state. But the end user will see that it's failed. They'll enter their PIN code. And in this case, they also have to accept terms and conditions. And the reason I include that is because that is also a blocking event. But you won't see that in the logs because it's already failed at that first blocking event. So sometimes it's a bit more frustrating to troubleshoot because you only see one of them at a time. Eventually, we come back, we see it's failed, we have all that, we do the terms and conditions, cool, everything's good there, the user's like, oh, okay, whatever, I'll do this. Well, once that device is unlocked and those terms and conditions are agreed to, the update's going to kick off and begin that verification and install process. And once that happens, we'll see in the logs that the failure reason's gone and the install state has flipped to repaired. So the next step in this is a little bit more time. That log empties out rather quickly because there's no update that's needed, and the user gets that beautiful end user notification that it's been successful. So those are my 3 debugging examples. Again, just really scraping the barest bit of the surface of debugging for these. But it's really important to do these tests so that we can provide feedback, especially when you're debugging some of the new declaration management stuff. So I'm going to go through and give some just quick points on how you might better provide feedback as you're testing to make sure your organization has all the workflows in place that it needs before Apple goes from deprecated to dead. So if you're not in Apple's seed program, get in it. Like, please, it's so helpful. If you have Apple School Manager, Business Manager, or Business Essentials, you're eligible for the beta programs. They're super helpful, especially when you're testing things like this, because you're able to go through, get additional documentation like that battery charge state needed that I mentioned. They have some example config profiles for testing, and you're able to use a settings declaration, automatically push that out. So super helpful, really great way to start that testing early. Also, as someone in product management, if you file your feedback when it's in a beta, it's gonna get fixed a lot faster. Now, if you have other feedback, say you have something that is MDM vendor specific, you'll contact your MDM vendor via their support. You're gonna wanna include logs, screenshots, some other helpful things, what did you expect to happen? What actually happened? And how to reproduce it. Let them know kind of the details of how you're testing it so they can help you and ideally fix it. Now, if it's Apple-specific feedback, it's a bit trickier. You're going to want to, if at all possible, file feedback from the impacted device first. The reason for this is Apple's ticketing system tags it differently. So if you grab the exact same logs, but transfer them to your production machine and file it, it's tagged differently and won't be touched as quickly. So if at all possible, do the first ticket filing. You can do updates from your production machine or any other machine to that, but it's really important. The other really important thing to make sure that the feedback is addressed quickly is make sure that it goes to the appropriate place for where that device is located. So if you're in the beta software program, file the feedback in the beta software program. If you're in the developer program, do it in the developer program, etc. So that's really important because what we found is just the simple thing of not filing it in the right place or not filing from that impacted device can significantly delay when something gets addressed. So it makes a big difference. Not always possible, but hey, you can try. And with that, I've gone through an absolutely ton of stuff very quickly. If you have any questions, I'm out there at the Addigy booth today. Otherwise, we are going to do some MDM vendor agnostic Q&A sessions via Zoom later this month in a couple different time zones. Please feel free to scan the QR code. This is a topic that myself and a couple of my product managers are kind of nerds about because we've been on the other side of the table and felt the pain. If you're interested, you can also have us chat with you. We'd love to understand the workflows, the pain points you're seeing, anything so that we can make the process better for the whole industry. You don't have to be an Addigy customer, but we would love to talk to you if at all possible. I'll also say, if you haven't entered our raffle for the AirPods, we're closing the sign up at lunch, so try to win some. With that, thank you all very much, and enjoy.